Hello and welcome, and in this video I'm going to show you how you can make procedural grids. With the plugin installed, we can in Game Engine model the grids you want and then bake the results instantly. To start building the grids, we're going to start from a box shape. So place down a box. I have some shortcuts for this, so if you would right click and edit the tool, you can go to the hotkey, and I edit the hotkey here so I can easily access basic shapes in Houdini, like this. So that's something interesting to know. Once I got my box shape, manipulate the box a bit more to a shape that I want. So I can, for example, make the grid look like this. After that, I'm going to use the axis align to make sure the box is perfectly in the middle of the world. Then I'm going to split my box in two, so I have my crate and then I also have a top panel for the crate to close it. I'm going to use a boolean for this, and I will be using a grid, and I'm going to change the rows and columns to 2 and the size can be 4. So based on where the plane will be, there will be a line. So but right now everything under the grid is shown, but we also want to see above the grid, and I'm going to use a scatter. So you can see it's now cutting the box in half. Then I would place a null node here and call it in. And we can use this input node and we will reference it here in the center. So what I first want to know is how big is my current box. So I'm going to use the bounding box. I'm going to ask from the in node that I just made. And now the size that I want to know is how high is it, so the y-axis. So y size. So if you place that, the grid will be here, and if you multiply this by, for example, 0.8, so it will always be like 80% is the grid and 20% will be the top part. So now going back to the main box, if I increase this now, we can see that everything is going nicely with it. So even if I go small, it still keeps that ratio. The nice thing about using a null node is that we can easily plug something else in here and the system still works because it's linked to the in. Then in this boolean, I also want to enable the only A pieces, and I'm going to use this to split up the parts from each other. So using a split and then filling in the A pieces, then we can see that we have now separated these parts. So next I'm going to create some null nodes, and I'm just going to call this in part 1, and then copy this and it will rename automatically, and then this is in part 2. So we're going to first start by making the grid. So first I'm going to make a group, select the top primitive, so I'm going to fill in the name top prim and use the normals and look at everything that's facing up. Then this can be blasted away. Then I bevel the results we have now, and then I will be polyfilling this result and set it to a single polygon. So the reason why I deleted the top first is so the bevel is not on the top, because we will have this part sitting on top of it. Then in the polyfill we can use the patch group, and this is a group with the polygon that it created, and I can use this in an extrude. So I'm gonna go here, patch, and then if I just scroll my mouse I can already see the inset going on. So let's say I want something like this, and then also here we're gonna have to enable a group. If I go here to the front group, I want to enable this, and I can use this then in a other extrude node. So in here I'm going to use front group, and I'm going to drag it down so we can put something in the crate. So with the current system you have to watch out that if the inset is too big, this will happen and points are actually overlapping with each other. So we can see that there are multiple points here. So what I do as a safe system, I place a fuse down here. This is going to fuse the points, and this will fix the problem, so we don't have this issue of these overlapping points. Then I want to have a subtle bevel on the edges, and we can actually use the extrude node. If you look closely to the red and green lines, we can output these as groups. These are called front boundary group and back boundary group. So the red one is the back and the green one is the front. So what I want here, let's say I want the back, and if I go back up to the first extrude, we also need the back one here. So, and if I now use the bevel and then use the back groups and lower the intensity, I have now made a bevel here. So I'm then gonna play around with the shape of this bevel by going to profile, and I'm just lower the last value, and I can have, for example, something like this. Next, what I want to do is I want to boolean some interesting shapes on the sides of the grids. So I'm gonna use boolean and I'm gonna subtract from the shapes, and I know that only on the sides I want to do a boolean. So I'm gonna extract the sides of the grid, and I'm gonna copy the group we made here, and I need to do this one more time with the group, so I have the down part also. So we have a group that selects the top and a group that selects the bottom, and then we're gonna blast them both the way. And now we are having the sides, and I can use this information to create some shapes out of it. An easy way to do this is by using a extrude node. Then I want to set the divide into individual pieces. So if I now, for example, would extrude, we can see that they're individual compared to the connected components. So in here, I will be going to disable the output sides and go into the spline control and play around with the thickness scale. And the reason why I play around with the thickness scale and not the inset is because if I play around with the inset value, this happens when values are getting larger compared to the thickness scale, which sort of like keeps the main size. Then this shape that's now being created, I'm gonna give it some thickness, and I'm gonna use the GameDev thicken for that. And I'm gonna add thickness in both directions. Notice that we now have created this line in the middle here, and we can easily get rid of this by using the flatten edges. And now the line is gone there. Then this shape, we could already plug it in the boolean, and this is then what happens. So you can see that maybe the thickness is here too much, so I'm gonna lower it, so we have something like that. And I'm also going to bevel this result. If you want to have some beveled edges, that would be nice to have. So this already gives us nice shapes that will procedurally follow. Then if I would quickly go back up to my original box, and if I would change some values, we can see that everything stays in the same ratio. Later, when creating an HTA, I will make this a multi-parameter. The reason why I'm going to make this a multi-parameter is we can control how many times I want to do this boolean. So if you give this tool to an artist, he can say I want this boolean to be 5 times, and he can also specify in which region by changing some of the values. So he can specify where he wants all this boolean action to happen. So we can also add some variation version of this. Let's say I want to boolean something from the bottom, and I will be going back here and we'll be using the blast and delete the bottom and delete non-selected. And I will basically do the same thing as I did here, so I will copy this for the moment. So this is the result, and then we merge these shapes, and I have at the bottom also a subtraction. If we go back to the extrude and increase this value higher than 1, like 2, we just get away the bottom part of the box, which can be nice in this case. Then another boolean I can do is, let's say I want to boolean something out of the corners. Then I can also use this the bottom shape, and I can use these points to copy a shape on it and then subtract it. So, but first of all, we need to get some normal information in the points. So I'm going to use a polyframe. And in this polyframe, I'm going to disable the normal name, and the tangent name will be changed to N. Then the style is then first edge. If I would now enable the normals, we can see that the normals are now following their edge. If you set this to 2 edges, they will be all facing sort of to the middle. This is not really what I need, so I'm going to set it back to first edge. So on these points, I will be placing down a box, and we can copy to point the box on the points, give the box a better size, maybe something like this, and I'm also going to rotate the box by 45 degrees, and let's merge this in the boolean and see what we are getting. And this already gives us something, but this is a bit too extreme, so I might move the box so it's just like a little bit on the shape. So if I move this up or down, we can then decide where we want this cut to happen. So we can, for example, create something that looks like this. What I also would like to have, I want something here to replace this the emptiness we made. I'm going to use first a transform, and we'll be using the original crate shape, and I'm going to scale it a little bit down, let's say something 0.98, so it's like a little bit smaller. Then using a boolean, and then I use the corner points and fill it in here. So we have extracted this shape, and then I'm going to merge this result together, and then we have something like this. So you can go back to the transform and play around with the scale, so you can go from out to inside if you want that. And this is then our basic crate. So we can easily go back to, for example, the beveling, and we can, let's say I want some more smoother bevels in the corner, we can have that. So this is then this crate part, and I will be moving it here. Then I will be making the top panel for the crate. So we have this boxy shape. Then I will be going to use a very similar approach of what we did earlier, and I basically gonna first copy paste the whole system and then delete and adjust what we needed for the top part. So let's see how this goes. So we can see that some parts are not really working that nicely. So let's first look at the main shape of the panel, and we can see that this extrusion that we did is of course way too much compared to what we want. And we also we want actually this extrusion to be happening on the other side. So I'm just gonna go to the group, and I'm gonna flip the direction to -1. So this looks way better. Then for the booleans, so let's first check the first boolean. So we can see that some of the logic also here has to be adjusted. So I like the side booleans, but I don't like the corner one and the one on the bottom. So here are one for the bottom. Let's just change this from down primitive to top primitive. And this already looks a bit better. So right now we have this big shape boolean from the top. And then we have these corner pieces, but I will be deleting them here because I don't want these corner pieces for the top panel. So now we have a panel that looks like this. Then I'm gonna make some variation in here, and I will be going to the poly extrude here from the one from the top, and it's set to 2. I'm just gonna set it to something like this. Then I want to make some sort of like a pattern here, and I will be using starting from this shape, and it will divide the shape. So it has this line. Then I extrude. In the extrude, I'm going to disable output and set it to individual, and I'm going to give it an inset, something like this. Then these shapes can be also extruded and output back. Then I want to boolean these shapes from each other, something like this, and then merge these results. So we have like this panel laying on top of it. We can also go back to the thicken here and make it a little bit lower if you would like to. Then I'm gonna merge the two panels together to keep everything a little bit clean in the network, I'm gonna use a null node here and call it out part 2 and copy the null node, and here got out part 1. With an object merge node, I can drag and drop these in the object, so they are now sort of like linked to each other. And I will be doing the same for the other one. And then I can now merge these together. And I can continue building them further than here later on for high poly and so on. So this is then the look of my crate I currently have. As it is procedural, we can always go back here and make it something look like this if you want to, or you can make it bigger. One more thing you can do with the part 2 of the grid, the top part, is you can, for example, place down a bar along the grid, and I will be going back here to the original shapes and copy the blast and delete non-selected. So we have this plane, and I want this plane actually to be in the middle of this cube, and I will be using a transform. And then we need to procedurally move it to the center. What I will be doing for that is in the transform, I'm going to create a spare input. And in this spare input, I can reference this null nodes in part 2. So I can drag and drop it. And now we have linked these nodes sort of together. You can see it by the line. And I want to, in the up axis, the y axis, I want to ask how big is the box. So bounding box. And to access the spare input, we're gonna press -1. So 0 is itself, -1 is the spare input. And I want to know the y size of the box divided by 2, of course. And then we know the center of the box. Then I use a poly wire. And this will then create sort of the handle. I will be lowering the radius and I increase the divisions to 6. In here, in a transform, and here I also want to scale this shape a bit down. So I'm going to do 0.9 in the x and y axis. If we merge this result, we have then now this cable, so it's a little bit too big here now. So something like this. Also based on how much depth you're gonna give this boolean, it's easier then to see this handlebar. What you could do to clean it up is you can use a boolean here, and you can use the shapes that we have from this boolean. So all the overlapping pieces that we would have are now gone, and we could use this instead of the other shape. So this is how the grid looks now. One more detail I'm gonna add to this crate is locks. So for the locks, I've pre-made some locks, so you can model a lock that you want on the crate. So this is how my lock will look like. So then I'm gonna build the system on how we can place them. So first, what I want is the bounds of my in part 2. Then it will look like this. So if I enable the primitive number, you can see the numbers, and I know for a fact that 2 will always be facing in this direction. So that's really useful to know from the bounds nodes, is that these numbers don't really change. So I want, for example, number 2, and so let's say I want my locks to be on the side of 2, so my locks will be here and here, and also want them on the other side, for example. Then I'm going to use the top points of these primitives to copy paste the models on. So I'm going to transform them and scale them a bit closer to each other. So if I'm going to view my box here, so I want my locks to be around this point, otherwise it would be on the side, which doesn't make sense. So I want them around here, for example. Then I will be using a normal, so we know that they are always facing in the right direction. So if I enable the normal, so you can see we want them to face in that direction. Then we don't want the bottom ones, and we know that the bottom ones are on point 0. So I'm gonna blast them away based on the number. So if I would double check this by going in the sprite sheet, so I can see that the points from 0 to 3 are having the value 0. So these can all be deleted because we only want the top ones. So in the blast node, I'm gonna say add points.y. If they would be bigger than, let's take 0.1, then you can delete them. And we have to set this to points. And then the only thing that we need to do here is copy to points, fill in the points, fill in the model, and then I have copied them. Of course, my models are too big and in the wrong rotation, so I will be using a transform, and I will be transforming them in the right direction and scale them down by as much as I need. And I can merge this with the result, and I'm gonna render this as my output so I can have a good idea of where my locks should be. And I see that they are still way too big, so I'm gonna make them way smaller, maybe something more like this. So I'm also gonna position them a bit better. I think here would be a better fit with the shape, or I can just go back here and adjust this size so I make some room for the locks. Then I also want to move them in a better position. So based on how you're gonna model your lock, you're gonna have some personal adjustments on your side. So based on this blast node, I actually decide where lock should be. So if I would, for example, only on the one side want some locks, then I would go back to the blast and change the value. So you can see that only here we have these locks. So this was the first part of the tutorial. Next part is going to be creating a digital asset or HDA, so we can use this crate in Unity.